Hey guys, welcome to my channel. So today we are going to discuss about the Singleton Design Pattern in Java. So let's get started. Now understanding the Singleton Design Pattern. The Singleton Design Pattern comes under Creational Design Pattern. It ensures that only one instance of a class is created in the JVM. It is used in logging, caching, thread pools, driver objects, configuration settings, etc. The Singleton Pattern concepts. Now there are several approaches, but the basic concepts are a private constructor. Now this will prevent anyone to instantiate the class. The second one being the private static variable. This is the only instance of the class. The static public method. Now this is the global access point for the outer world to get instance of this class. Now we have to keep these three in mind while creating a singleton class. Now we have to understand what is eager initialization. Now in case of eager initialization, it is created at time of class loading even though client application might not be using it. Let's have an example. Public class eager singleton, private static final eager singleton instance equals new eager singleton. Now we would be having private constructor to provide client application to use constructor. Now the next would be the get instance method, public static eager singleton get instance. Now this would be returning the instance. Now this is an example of eager initialization. What is static block initialization? Now it is similar to eager initialization except for instance getting created in static block, which is option for exception handling. Now we will be having a look at the code. Public class static block singleton, private static block singleton instance, then followed by the constructor. The constructor is private. Now we would be having the static block like this. Again we have the get instance method, which is public static, would be returning the instance. Now this is an example of static block initialization. Now let's look at lazy initialization. Now in this case, the instance is created in the global access method. Now we would be having a look at the code. Look at the constructor, it's private. The instance is private static. We are not creating the instance as in case of eager initialization. Now in the get instance method, we are checking if the instance is null, then only we are creating the instance of lazy singleton, and we are returning it from the get instance method. So that's an example of lazy singleton. Now looking back at lazy singleton class what we have created, now this works fine in single-threaded environment, but in case of multi-threaded environment it can destroy the singleton pattern. Suppose if two threads get different instances of the same class. So what we will be creating is a threads of singleton class in our next example. Now let's have a look at threads of singleton class. Now for threads of singleton class, we need to make sure that the global access method is using the synchronized keyword so that only one thread can execute this at a time. So let's have a look at the code. So we are doing everything the pretty much same that we did before, but we are using the synchronized keyword in case of the get instance method. So this is an example of threads of singleton class. Now what is the drawback of this threads of singleton class? By using the synchronized keyword, we can prevent thread 2 or thread 3 to access this method while the thread 1 is inside the method. So every time the method is called, there is an additional overhead. So we would be using double check locking in order to overcome the drawback of the threadSub class that we created before. So in order to overcome this drawback, we are using double check locking to limit expensive operation. Now let's have a look at the code. Now see, everything is pretty much the same. So what we are doing over here, we are checking if instance equals null, then we are calling this synchronized block, and then again we are checking if instance is null, then we are creating the instance of the class, and then we are returning the instance. Now this is how a double check locking looks like. So why it is double check? Because we are checking twice. Where we are getting inside the get instance method, then we are checking if instance is null, then only we are getting inside the synchronized block, and again we are checking if instance is null, then we are creating the instance of the class. So that's why we have named this as double check locking. Now understanding the double check locking. Now this is the class. So it's pretty much the same code that we discussed before. Now suppose we are encountering a multi-threaded environment and many threads tries to access a new instance. What will happen in that scenario? Suppose there are 3 threads and the only one thread will be given access while the rest of the thread will be waiting on the synchronized block. So 2 threads have entered inside the first null check, and the first thread has been given access to the synchronized block. Now the second thread would be waiting on the first thread, because when the first thread exits the synchronized block, then only the second thread would be entering it. So at this point of time, the instance is null. So the scenario is somewhat like this, that the second thread is waiting on the first thread, which is inside the synchronized block. Now when the first thread exits, then the second thread will be given access. Now when the second thread enters, it will be prevented to enter further due to double null check, because when the first thread exits, at this point of time the instance is not equal to null. So the second thread is prevented to enter the second if condition. Again, suppose another thread tries to access the new instance. What will happen in that case? Now since the first thread has the instance, no other thread will be allowed to enter the first if check. So when a third thread comes into scenario, then it will be prevented to enter just at the very first if check. So that's how we are limiting this expensive operation. I guess by this time you have understood what a double check locking looks like and how it works. Now what is the drawback of double check locking? To understand this, first we need to understand the object creation process. Now the object creation process can be broadly classified into 3 steps. First is allocating memory to an object. Second is executing code inside the constructor. Third is assigning memory reference to the field. Now the problem is some of the JIT compilers, which is the just-in-time compiler, reiterates the last 2 steps mentioned above. Now in that case, instance variable will be assigned null reference and constructor code will be executed. Now we need to understand the concept of half-baked object. Now suppose if an object is assigned non-null reference and code inside the constructor is still being executed, then the object is not fully constructed or baked, and this is called half-baked object. Now by this time, if you are not clear about what a half-baked object is, just pause the video, go a couple of seconds and rewind it just to understand what are the steps of object creation. I'm sure you will understand it. Now what is the drawback of the double check locking class that we created? Now assume thread 1 is executing this line where it is executing the constructor call. Now that means that thread 1 has its null reference to its instance variable, but it has not completed the constructor call. So that means there is a half-baked object at this point of time. At this very moment, suppose thread 2 enters the getInstance method and has reached the first null check. So what will happen? Now instance is not null because it contains the half-baked object, right? As a null instance has already been assigned by the previous thread, so it will not enter the if block and a half-baked object is returned, right? So this is the problem with the double check locking method that we discussed before. So what is the solution to this? Now the solution to this is we need to declare the instance variable as volatile, because a volatile instance guarantees completion of all steps of object creation before another thread reads the reference from the instance variable. So how a double check locking class would look like with a volatile instance. Now notice the volatile keyword used over here with the instance. The rest of the code would remain the same. So by this time, I guess you are pretty much confident on Singleton Design Pattern. And if you like this video, please give a thumbs up and don't forget to subscribe to our channel. We will be coming up with more videos like this. Thanks for watching.